You have been stressed for so long, you have forgotten what normal feels like. Not the acute stress of a deadline or a difficult conversation, the other kind, the low-level, constant background kind that has no clear source and no clear end. The kind that makes you irritable for no reason, forgetful in ways that scare you, and exhausted by things that used to be easy. You have probably told yourself it is temporary, that once things settle down, you will feel like yourself again. Here is what nobody tells you. Chronic stress is not just an experience, it's a construction process. And while you have been waiting for things to calm down, your brain has been quietly rebuilding itself around the stress. Not metaphorically, structurally. This is what it has been doing. Chapter 1. 5 things chronic stress does to the brain. Effect 1. It shrinks your hippocampus. The hippocampus is the brain region most critical to memory formation, spatial navigation, and contextual learning. It is also the region most densely packed with cortisol receptors, which makes it the most vulnerable to sustained stress hormone exposure. Robert Sapolsky at Stanford University has spent 4 decades documenting what chronic cortisol elevation does to hippocampal architecture. The findings are unambiguous. Sustained cortisol exposure inhibits neurogenesis, the birth of new neurons in the hippocampal dentate gyrus. It causes dendritic retraction, the physical shrinking of the branching extensions through which neurons communicate. And in cases of prolonged chronic stress, it produces measurable reductions in hippocampal volume visible on structural brain scans. The cognitive consequence is what you already recognize. Words that used to come easily do not come at all. You walk into rooms and forget why you went. You read something and retain nothing. This is not distraction. This is a memory system operating with degraded architecture. Effect 2. It rewires your threat detection system. The amygdala is your brain's alarm system. Under normal conditions, the prefrontal cortex regulates its output, contextualizing threats and modulating the fear response so that you can function under pressure without being overwhelmed by it. Chronic stress dismantles that regulatory relationship. Bruce McEwen at Rockefeller University documented how sustained cortisol exposure causes dendritic growth in the amygdala while simultaneously degrading prefrontal regulatory capacity. The result is a brain that becomes progressively more reactive and progressively less capable of modulating that reactivity. Your alarm system grows louder, the volume control weakens. This is why chronically stressed people often describe feeling on edge without knowing why, snapping at people they care about, interpreting neutral events as threatening. The threat detection system has been recalibrated by sustained stress exposure to detect danger everywhere. It is not paranoia, it is a structurally altered brain doing exactly what structural alteration produces. Effect 3. It degrades your prefrontal cortex. The prefrontal cortex is the seat of everything that makes deliberate human behavior possible: planning, impulse regulation, rational decision-making, emotional modulation, working memory, the capacity to consider consequences before acting. Chronic stress degrades all of it. Amy Arnstein at Yale University has shown that even relatively brief periods of uncontrollable stress cause a rapid and significant reduction in prefrontal function through a mechanism involving norepinephrine and dopamine receptor signaling. Chronic stress compounds this. The prefrontal cortex physically thins under chronic cortisol exposure. Dendritic complexity reduces, synaptic connections weaken. The consequence is a brain that knows what it should do and cannot make itself do it, that struggles to plan beyond the immediate, that makes impulsive decisions it recognizes as impulsive in the moment and makes anyway. People experiencing this often describe it as not feeling like themselves. They are correct. The brain generating their behavior is not the same brain they had before the chronic stress began. Effect 4. It disrupts your neurochemistry. Cortisol does not operate in isolation. It interacts with every major neurotransmitter system in the brain. Sustained cortisol elevation suppresses serotonin synthesis and receptor sensitivity, the system most associated with mood stability and emotional resilience. It disrupts dopaminergic signaling in the prefrontal cortex and striatum, degrading motivation, reward anticipation, in the capacity for pleasure. It elevates glutamate to neurotoxic levels in the hippocampus and prefrontal cortex, causing excitotoxic damage to the very neurons stress is already compromising through other mechanisms. The experience of this neurochemical disruption is what clinical literature calls anhedonia. Things that used to feel rewarding no longer do. Food, socializing, hobbies, rest. The brain has lost the capacity to generate the signals that make experience feel worthwhile. This is not a mood, it is a system in chemical dysregulation, and it does not resolve by waiting for circumstances to improve. Effect 5. It triggers neuroinflammation. This is the mechanism that connects chronic psychological stress to long-term neurological disease risk. The brain's immune cells, called microglia, are sensitive to stress hormone signaling. Under chronic stress, cortisol and accompanying inflammatory cytokines produced by the peripheral immune system cross the blood-brain barrier and activate microglia into a pro-inflammatory state. Activated microglia begin degrading synaptic connections they would otherwise protect. Research published in journals including Biological Psychiatry and Nature Neuroscience has linked chronic psychological stress-induced neuroinflammation to increased risk of major depression, cognitive decline, and accelerated neurodegenerative disease progression. The pathway from chronic psychological stress to structural brain damage is not theoretical. It is documented, mechanistic, and dose-dependent. The longer the stress continues, the greater the cumulative inflammatory burden. Chapter 2. Why time off is not enough. Here is the part that most stress management advice skips entirely. The changes described in Chapter 1 are not functional, they are structural. A hippocampus with reduced volume does not restore itself over a long weekend. An amygdala recalibrated toward hyperreactivity does not return to baseline because the stressor is temporarily removed. A prefrontal cortex thinned by sustained cortisol exposure does not regenerate because you took a holiday. Structural change requires structural intervention, and the timeline for neural recovery is measured in months, not days. This is not pessimism. The brain retains neuroplasticity throughout life. Neurogenesis in the hippocampus continues in adulthood and can be upregulated with the right inputs. Dendritic complexity can be restored. Prefrontal function can recover. But none of that happens passively, and none of it happens fast. The first requirement is reducing the cortisol load, not managing stress better, actually reducing the chronic activation of the HPA axis. That means addressing the sources, not just the symptoms. Chapter 3. What actually reverses the damage? Aerobic exercise is the single most evidence-backed intervention for reversing stress-induced brain damage. It elevates BDNF, brain-derived neurotropic factor, which directly stimulates hippocampal neurogenesis and supports dendritic recovery. Kirk Erickson at the University of Pittsburgh demonstrated that aerobic exercise increased hippocampal volume by 2% in adults, directly reversing age and stress-related shrinkage. 30 to 40 minutes, 3 to 4 times per week at a sustained moderate intensity.
Sleep, specifically slow-wave sleep, is when cortisol clearance and HPA axis recalibration occur. Protecting sleep duration and consistency is not recovery support. It is the primary mechanism of neurological repair. Without it, every other intervention is working against an unresolved deficit. Social connection with people who generate felt safety reduces amygdala reactivity through oxytocin-mediated suppression of the stress response. Not digital connection, physical proximity. The nervous system co-regulates with other nervous systems. Isolation maintains the threat signal that chronic stress installed. Focused attention practices, including meditation, have been shown by Sarah Lazar at Massachusetts General Hospital to increase prefrontal cortical thickness and reduce amygdala reactivity over 8 weeks of consistent practice. 10 minutes of genuine practice daily, not guided relaxation, not background audio, changes the structural relationship between your prefrontal cortex and your amygdala. Here's your challenge. Tonight, before you sleep, write down the 3 most persistent sources of stress currently active in your life. Not to solve them, to externalize them. Get them out of your nervous system and onto paper so your brain stops holding them in active memory overnight. Then commit to one thing tomorrow, 30 minutes of aerobic movement at a pace that elevates your heart rate, not as a productivity strategy, as a direct neurological intervention. That is where the recovery starts, not with time, with input. Chronic stress is not a season you wait out. It is a construction project happening inside your brain, whether you are paying attention to it or not. The damage is real, the mechanisms are documented, and the reversal is possible, but only if you stop treating a structural problem like a scheduling inconvenience. Your brain built itself around your stress. With the right inputs, it will build itself back. That is neuroplasticity. That is what this channel is about. Subscribe if you want to keep going. Every video here is the same, the science underneath what you are experiencing and exactly what to do about it.